All right, number 14. The integral of x squared plus square root of x cubed minus 2 over x cubed. This is just general antiderivative, so this becomes x to the third over 3. Now for this expression, you should know that that means it's x to the 3 over 2, so that's what that means. And its general antiderivative would be adding 1 to the exponent and then multiply it by, and then divide it by 5 over 2, but dividing it by 5 over 2 means multiplying it by 2 over 5. And then for this other function, you want to write it as a power function so that it's easier for you to take the antiderivative. So I will be adding 1 to it. If I add 1 to it, I get x to the negative 2. And then I'd also divide it by negative 2. So these cancels out. Don't forget to do a plus c. So when you write down the final answer, it should look something like this. Okay, plus c. Okay, that is number 14. Okay, number 15. Antiderivative of sine of 2x plus cosine of 2x dx. This is just general antiderivative. So the antiderivative for sine of 2x is going to be negative cosine of 2x. And then you multiply it by 1 over the derivative of the inside, which is 2. Okay. The antiderivative for cosine is sine of 2x. So whatever is in there goes in there. And then you multiply it by 1 over the derivative of the inside, which is 2. And then you add a c. And you're done. Okay, good. Number 16. The antiderivative of x squared minus 1 times x minus 1 dx. I would distribute first, so then you get x to the third followed by x squared followed by negative x followed by plus 1, and then I would integrate term by term. So the antiderivative of x to the third is x to the 4 over 4, x to the 3 over 3, x squared over 2, and then that's x, and then you add in a plus c, and you're done. Okay. Number 17. The antiderivative of tangent of x dx. For this one, we'll need to do a u substitution. Before we do a u substitution, we need to know that tangent is sine over cosine. So let u equal to sine of x followed by du is, u is cosine. Okay, sorry about that. U equals to cosine, du equals to sine of x dx. And then we make a substitution. First, sine x dx is replaced with du. And then cosine is replaced with u, so then you have the antiderivative of 1 over u. That equals the ln of u plus c. And you plug in what u is. In this case, u is cosine of x plus c, and there you go. Okay. Number 18. Okay, let's finish number 18. Number 18, the antiderivative of 3x squared cosine of x cubed dx. Like that. So we use substitution. Let u equal to x cubed du equals to 3x squared dx. There is your 3x squared dx. We replace that with du, and then we replace x cubed with u. That's what we'll boil down to. We find the antiderivative of that, which is sine of u plus c. and we plug in what u is. U is x cubed, and we're done. Number 19. The antiderivative of 3 cosine of 2 plus 3x dx. Bring the 3 to the front. Okay. We can do it just by the general antiderivative. Leave the 3 alone for now. The antiderivative of cosine 2 plus 3x is negative. It's just sine of 2 plus 3x. So it's sine of whatever is in there. But you multiply it by 1 over the derivative of the inside, which is 3. Okay? And we add in a c. Now don't forget to bring down the 3 there, so bring that down. And if you bring that down, these two, they'll cancel out. So this is what we have as our final answer. Okay? Very good. Number 20. The integral of cosecant x, cotangent of x dx. Okay, so the antiderivative of cosecant of x times cotangent of x. To help you out, okay, make sure you memorize your formula, your derivative formula. This is one of those antiderivative formula. It's negative cosecant of x plus c. So negative cosecant of x plus c. Okay? And then number 21, antiderivative of cosecant of square of x cotangent of x dx. Now to complete this problem, we have to do a u sub. So we let u equal to cotangent of x, then du equals to negative cosecant square x dx. Okay, so here's your negative cosecant square. We perform a substitution. So we're going to get negative du, and we replace cotangent with u. So you have negative integral of u du, because this whole thing, this thing and that thing is du. This thing is u, so that's what you're replacing with. And by integrating, you are going to get u squared over 2. Last thing is you replace what u is, so u is cotangent of x over 2, square it plus c, and you're done. Okay? So make sure you review these problems, very important problems. In class, we'll do tons of classwork to get you more practice, but it's important that you practice these problems so that you are familiar with the integration technique. Again, don't forget to go over the antiderivative formula. Make sure you memorize all of them, okay? But memorize the very most important one at the very least. All right.